You think you understand big. You don't. Your brain evolved to judge the distance to a predator, the size of a cave, the length of a river. It was never built for this. Earth feels massive, 40,000 kilometers around, a planet you could never walk across in one lifetime. That feeling is already wrong. Compared to what actually exists out there, Earth is not big. It is barely a starting point. What follows is not a list of impressive numbers. It is a ladder. Each step will make the one before it look small, then laughable, then meaningless. By the end, we reach something that, according to the laws of physics, should not exist at all. Somewhere along the way, your intuition will simply stop working. It won't slow down. It won't warn you. It will just fail. That failure is the entire point of this video. Start with what you think you know. Earth, about 40,000 kilometers around the equator. Say the number out loud and it sounds concrete, almost manageable. It isn't. No human being has ever truly felt that distance. We experience kilometers, maybe a few hundred on a long drive. 40,000 is already an abstraction, a number we accept rather than understand. And this is supposed to be the object we grasp best, the one we stand on, the one we can touch. Now take that planet, the one already too large to picture, and multiply it. Jupiter. Alone could fit more than 1,300 Earths inside it. Not lined up, not stacked, contained. An entire planet, the one that holds every ocean, every mountain, every person who has ever lived, would be one of over 1,000 identical spheres crammed into a single gas giant. And Jupiter is still in our own backyard, still orbiting the same star, still, by cosmic standards, close enough to be called a neighbor. This is the pattern for everything that follows. Something enormous appears, forces you to recalibrate, and then gets swallowed by the next thing in line. Jupiter feels impossible right now. It is nothing. The Sun comes next, and the number attached to it stops sounding real. More than 1 million Earths could fit inside it. Not Jupiter, Earth. 1 million of them, packed into the object that quietly sits at the center of everything we know, the one we barely look at directly because it burns too bright to face. And here is the deflation. The Sun is not special. It is a G-type yellow dwarf, a completely average star by the standards of the universe. Not the biggest, not the brightest, just ordinary. The object that makes life on Earth possible, that 1 million Earths could vanish into, barely registers as impressive once you compare it to what else is out there. There is something else worth remembering here, something that will matter later. Size and mass are not the same thing in space. An object can be enormous in volume and relatively light in weight, or the opposite, small and impossibly heavy. The Sun is large and ordinary. What comes next is large in a way that makes the Sun look small again. This is UY Scuti, a hypergiant, and currently the largest known star in the universe. Its radius is roughly 1,700 times that of the Sun. Not its mass, its size. Picture it differently. Take UY Scuti and place it where our Sun sits right now, at the center of the solar system. Mercury disappears inside it. Venus disappears. Earth disappears. Mars disappears. The surface of the star itself would extend just past the orbit of Jupiter. An entire solar system swallowed, and that's before accounting for the gas and dust streaming off its surface, which reaches even farther, beyond the orbit of Pluto, hundreds of times the distance between Earth and the Sun. And now the twist that matters. Despite all of that, despite consuming everything out to Jupiter, UY Scuti is only about 30 times more massive than the Sun. Enormous in size. barely heavier in comparison. This is where the earlier warning becomes real. Size and mass have officially split apart. You can be almost incomprehensibly large and still not particularly heavy. Remember that split, because we are about to leave size behind entirely and move into pure mass, where the numbers stop being about volume and start being about something closer to violence. This is TON 618, the largest black hole we know of. It powers a quasar, and its estimated mass is 66 billion suns. Not 66 billion kilometers. Not 66 billion times the volume. 66 billion times the mass of the star that a million Earths could fit inside. Remember the split from before, size versus mass. TON 618 is the other extreme entirely. Black holes are not large in any way you can picture. They are dense beyond anything else in the universe, matter crushed into a point so extreme that light itself cannot escape it. There is no surface to compare to Jupiter's orbit. There is no edge you could stand at and look up. There is only mass, concentrated to a degree that breaks the usual meaning of the word big. For context, the black hole at the center of our own galaxy, the one holding the Milky Way together, has a mass of about 4 million suns. Against TON 618, it is a rounding error. We have now left individual objects behind completely. From here, the scale stops being about stars or black holes. It becomes about galaxies themselves. Reset the scale entirely. The Milky Way, our own galaxy, is about 100,000 light-years across. Light, the fastest thing that exists, needs 100,000 years just to cross from one edge to the other. That is now the unit we measure by. Not kilometers, not even the distance to a star. An entire galaxy becomes the new baseline for big. And then, IC 1101 appears, the largest known galaxy in the universe, stretching somewhere between 4 and 5.5 million light-years across. Do the comparison directly. IC 1101 is roughly 50 times larger than the Milky Way, and about 2,000 times more massive. Picture it the same way we pictured UY Scuti. Place IC 1101 where the Milky Way sits right now. Its edge would not stop at our galaxy's boundary. It would reach past Andromeda, our nearest large galactic neighbor, 2.5 million light-years away. One single galaxy, swallowing the entire distance between us and our closest neighbor, and continuing beyond it. Inside that structure sit stars, planets, black holes, entire solar systems, and yet astronomers still call it one object. IC 1101 feels like the ceiling. It isn't. Because galaxies themselves are not the largest things that gravity builds. They are simply the last object with a clear edge. Galaxies do not exist alone. They gather into clusters, and clusters gather into something larger still, superclusters. Our own galaxy belongs to one called Laniakea, home to roughly 100,000 galaxies, spanning more than 520 million light-years. Not one galaxy anymore. 100,000 of them, bound together, flowing through space as a single structure. We just went from measuring one galaxy to measuring 100,000. Beyond superclusters, there are quasar groups, clusters of the most violently bright objects in the universe, powered by black holes feeding on everything nearby. The huge LQG contains 73 of them, with an estimated combined mass of 6.1 quintillion suns, spanning close to 4 billion light-years. When it was found, it was the largest structure ever identified, and it should not have been possible. That word, should, matters here. Because in cosmology, there is supposed to be a ceiling. a point at which the universe evens out, where nothing coherent should be larger. The huge LQG pushed past it. It was not the last structure to do so. Something larger was still waiting, something that would not just bend that ceiling, but shatter it completely. This is the Hercules-Corona Borealis Great Wall, discovered in 2013 by a team led by Istvan Horvath. They weren't looking for a structure at all. They were mapping gamma-ray bursts, brief violent flashes released when massive stars die, scattered across the sky. Where mass concentrates, these bursts tend to cluster. And in one direction, toward the constellations Hercules and Corona Borealis, they found far more than they expected. What they had found was a structure roughly 10 billion light-years across. Say that plainly, and it doesn't land. So translate it the same way as everything before it. Light, the fastest thing that exists, the same light that took 100,000 years to cross our galaxy, would need 10 billion years to cross this. The universe itself is only 13.8 billion years old. This single structure spans nearly its entire lifetime in distance. And here is the twist that changes everything. Modern cosmology depends on one core assumption, that at a large enough scale, matter should look evenly spread out, uniform, with nothing coherent bigger than about 1.2 billion light-years. This wall is nearly 10 times that limit. By the rules we use to understand the universe, it should not exist. Even the scientists involved have said as much. One co-author admitted he assumed it was too big to be real. A 2020 paper argued it might be a statistical illusion. The original team disagreed, defending their find the same year. No one has settled it. The largest thing we've ever found remains, officially, unexplained. Somewhere between Jupiter and a wall 10 billion light-years wide, your intuition stopped working. That was never a failure on your part. It was inevitable. The universe was never built to be understood by something that evolved to judge the distance to a river. We are creatures who struggle to picture our own planet, standing at the bottom of a staircase that ends in a structure physics says cannot exist. The largest thing we've ever found is also the thing we understand the least. Maybe that's fitting. I hope you enjoyed the video, and we'll see you next time.